This video clip is part of the EPFL introductory course on information computing and communication. It is the fifth and last one in a set of video clips on information storage and management. It offers a brief overview of the basic commands in the most common relational database language called SQL, for Structured Query Language. Hierarchical file systems are quite satisfactory for applications dealing with limited amounts of unstructured data, such as is often found on private personal computers. Some personal productivity applications, however, for instance large personal media library, and most business applications such as production, sales, financial, human resources, or other programs, do however manage huge quantities of structured data. Managing such data is complex and typically subject to strict consistency constraints. For instance, it would be bad if two computers tried to reserve the same airplane seat at the same time, or if a computer crashed between booking a plane ticket and charging for it. Avoiding such problems with only plain hierarchical file systems would be quite difficult. Relational database systems properly organize information into relational tables and are designed to handle such critical reliability issues, thereby relieving users from worrying about all of this. Files containing structured relational data are divided into records and fields. One record corresponds to one row in a relational table. One field corresponds to each column in that row. A typical example of a record could be a sequence of fields such as in a human resources database: surname, name, address, telephone number, register number, place and date of birth, salary, etc. Records are stored sequentially within such data files, each record being located by its own base or start address. In the overwhelming majority of relational databases, all records have the same fixed record length L, so that the database software knows that it can retrieve the kth record at the base address equal to k-1 times the fixed length L. Any variable length, possibly unstructured data in such a database, for instance variable length text, music or video information, is typically stored in a separate file, and the file for it in the main database is just a pointer to the base address of the variable length record in the separate file. As mentioned earlier, the most common language for managing relational data is SQL. In SQL, a relational table can be created using the create command, which initializes the name of the table. That command takes as parameters a list of the fields that will be contained in every record. This slide shows how one would create a database of staff or students called admin, showing for each person their surname, name, serial number, date of birth, address, and telephone number, and declaring that the primary key for indexing, sorting the relational database should be the name field. SQL provides the insert command to populate the content of such a newly created table. The insert command takes two sets of parameters in addition to the name of the table to be inserted into. The first set of parameters defines which of the fields should be filled by this insert command. Indeed, one need not fill all the fields with the same insert command. The second set of parameters then sets the initial values for each of the fields. This slide shows how the newly created admin relational table of the previous slide would look like after the given insert command on this slide. Of course, data in a relational database is not immutable. SQL offers the update command to change the value of selected fields in selected records. The update command also takes two sets of parameters in addition to the name of the relational table to be updated. The first set of parameters defines which field should be updated with their new values. The second set of parameters defines which records, or record if there's a single one, should be updated. This slide shows how the admin database would look like after the given update command. As explained in an earlier clip about relational data structures, a relational database may comprise multiple tables, and more relations can be extracted from these tables than the individual relations that each of them already represents. For this purpose, SQL offers the select command, which in effect reveals relations not directly visible in any table. The select command does not create any new table to represent the revealed relation. Instead, it merely returns to the querying user a list of the records and fields as they would exist in such a new table if it was created. The select command takes 4 sets of parameters. The first set indicates what the fields, columns, of the revealed relation should be, in this case, surname, name, and address. The second set of parameters indicates out of which tables the revealed relation should be extracted, admin, in this case, and a hypothetical ACAD database. Note that the same semantic field may bear different names in different tables, so the select command must also accommodate for that. In the present example, the SQL database must be told that the number field in ACAD is semantically equivalent to the serial number field in the admin database. The third set of parameters specifies criteria about the subset of records that should be selected for the revealed relation. In the example of this slide, we're interested only in records of students from the first bachelor semester who scored a grade above 4. The fourth and last set of parameters states which of the requested fields should be used to list the revealed relation in order. The bottom of the slide shows the relation, in this case a single record, that would be revealed by the given select command. If one would actually want to create a real new table out of 2 existing relations, one could use the SQL merge command. The syntax for doing so is not shown here, but the slide shows the result of merging the earlier ACAD and admin relations into a new grades table. Of course, just as SQL needs to provide the insert command to add records to an existing relational table, it also needs to provide a command called delete to, on the contrary, remove records from an existing table. This slide shows the result of the given delete command on the grades database built from the previous slide. SQL actually provides many more commands and many more complex parameters for the commands described earlier. The given commands do, however, give a good basic feeling for what SQL can do. Further details would be beyond the scope of this clip and uninteresting for this audience.